So your notes, 5-2, Part 2, rate of change notes. So what you're turning today are your notes and the worksheet. These are the problems you're doing. Notice you're not doing all the problems here. You're doing all of 1 through 15, and then you're doing 17 through 33 odd. 17 through 33 odd. Remember what odd means? 17, 19, 21, 23, 25, 27, 29, 31, and 33, in case you forgot what it means for them to be odd. All right. So we talked about slope yesterday. What is slope? Who remembers what slope is? Downhill, Shamari said? Kind of, you're on the right track. Bringing the number down. I might bring the number up, right? Not necessarily. What is slope? Rise over run is one of the formulas we learned or reviewed yesterday, right? Because all of this you have been taught before technically last year. So slope is the steepness of a line. And we can give it a numerical value, and we call that numerical value its slope. Well, today we're going to be talking about rate of change. So your first thing to write in your notes is rate of change is the same as slope. But it is the term that we use in a real world problem. So if we're talking about the rate of change, but it's a word problem, if we're talking about the slope, but it's a word problem, they're going to call it the rate of change. But the formula is the same. You can represent a word problem as a graph, so we could also use rise over run. You could also represent it with the formula y minus y over x minus x. That could be read as the change in y divided by the change in x. So I said over, but I should have said divided there, right? It's a division problem. So right now everybody's writing what I have on the board. Wasim, will you drop your phone in your backpack for me, please? If anybody else has your phone out, it needs to be dropped in your backpack. We're working on your notes now, Taj. Not that one, buddy. Fine now, it's going to clear. There it is. Just starting to write it down now, I'm going to have to come back and let you finish typing at the end because we're going to run out of time. I can't start late, and then I can't wait for you if you're not starting when we start. So Sam's got everything written. Jacob's almost done with everything. He's in the last line. Technically, we're not supposed to be doing that, right, Tyrese? Because your phone's supposed to be put away, right? And I am recording, so you can always go back to the video. I know I'm a big talker since I forgot to post a video yesterday afternoon, but I've been doing a pretty good job of that. So usually it's going to be posted at the end of the day. So remember, while y'all are finishing up, these y's represent the y coordinates in points on a coordinate plane. The x's represent the x coordinates of points on a coordinate plane. So rate of change is going to look a lot like slope, except we are going to get to some word problems today. We've done very few word problems this year, but we do have to do some word problems in this unit. All right, I'm going to move on, and we can come back to this at the end, or you can watch the video to fill in. All right, so I'm trying to think here if you have to write all this. I do want to read it all. So if a situation has a linear relationship, don't write everything yet. I'll tell you which part of this to write, okay? So if there's a linear relationship between data points or ordered pairs on the coordinate plane. The change in the y values from one y value to the next y value will be equal or the same. The change from one x value to the next will be the same. If they're the same, we say the rate of change is constant and the relationship is linear. Let's think before we write anything. Let's look at what the heck we're talking about. So we've got two different examples here. So go ahead and write this part. So write that is the rate of change constant. And then instead of making this table, you can just make yourself a T-chart. So that just means a line here and a line here looks like a T, right? And you're going to write an X and a Y, like I have here, and then write the numbers that I have in my table. So that's how you're going to copy it into your notes. Did you bring a pack? Did you not go to the clinic? Okay, so this is what yours should look like, maybe a little bit neater than my handwriting. So we're going to start with example 2, and we'll come over to example 1 in a second. So example 1, we see this table of values. So I want to know, is the rate of change or is the slope of this relationship, is at a constant rate of change? So do the x's all change by the same amount from one to the next? Do the y's all change by the same amount? So let's look. If we go from 1 to 2, what have we done to get from 1 to 2? We added 1. If we go from 2 to 3, what did we do to get from 2 to 3? Add 1. And from 3 to 4? Add 1. So far, from one x to the next, it's always the same change, right? The same amount of change. So let's look at the y values. So from 6 to 12, what do we do? Plus 6. And then from 12 to 18, also plus 6. And 18 to 24, also plus 6. So since the x's all change by the same amount from one to the next, and the y's all changed by the same amount, we can say, example 1, there is a constant rate of change. So example 1, there's a constant rate of change. So this table, just for the record, remember, also represents ordered pairs. So when you see this represents the ordered pair 1, 6. So when you see x and y up there, we know that's the x coordinate and that's the y coordinate. This ordered pair is 2, 12. Is this looking familiar from last year? This ordered pair, this 3, 18 is really the ordered pair 3, 18. Remember, ordered pairs, x coordinate and y coordinate, right? And lastly, 424, that's the ordered pair 424. You don't really need to know that right now to tell me if this is a constant rate of change or not. Since this has a constant rate of change, I know that it's a linear relationship. And if there's a linear relationship, then I can find the slope based on this table as well. We're not going to do that yet, but I'll go back in. Sorry. So because the x's change by the same amount, the y's change by the same amount, we say that there's a constant change. So the word same and constant fill in your X values and fill in your Y values. You have to be in the same order because remember they're part of an ordered pair. So X coordinates and Y coordinates of an ordered pair. So this is an ordered pair, this is an ordered pair, and so on. So the question is the rate of change constant, for example, 2? Well, let's start with the x's. So what do I have to do to get from negative 10 to negative 2? So I'm going from the left of the number line to the right of the number line, right? So we're adding 8. That's exactly right. So negative 10 plus 8 gives me negative 2. If I go from negative 2 to positive 6, can I add 8 to get from negative 2 to positive 6? I can, and you can check it on your calculator. So if you want to know the difference, you just subtract these. So on your calculator, you do negative 2 minus negative 8, and it would give you that difference. Now, from 6 to 14, can I just add 8 again? Right, 6 plus 8 is 14. So right now, it looks like this is a constant rate of change. But I have to check my y's now. So what do I do to get from 5 to 1? Subtract 4, right? So if I have 1 minus negative 4, if I subtract 4 from 1, do I get negative 4? What do I get? Negative 3, right? So that's going to be, if I go from 1 to negative 5, I'm subtracting 5, right? So that's not equal. So I can stop right there. I'm all done. Example 2, there's no constant. It's not a constant rate of change. So for example 2, it's not a constant rate of change. And so now I know that that relationship is not linear. I cannot write a linear equation to represent that relationship or that information in that table. It's not a constant rate of change. It's not a constant slope, if you want to think about it that way. So it's not a linear relationship. You caught up with me? Jeremiah? Sit. You're not caught up with me. We're all the way down to writing that example 2 is not a constant rate of change. Anybody need more time? Okay. A few more seconds. So the first 3 problems on your worksheet, you're going to use that strategy. That's how you do the first 3 problems on your worksheet. So you're going to see, does the x's change the same as the y's? So let's see. So if the x's, so this is what you're writing, last thing for this section. If the x's change by the same amount, let me look up here, I might not have to rewrite it. Okay. We're going to say here, if, we're going to scratch that for now for the sake of time, if the change from one y value to the next is the same, and the change from one x value to the next is the same, the rate of change is constant. So I'm going to scratch out the stuff you're not writing. And the relationship is linear. So here we go. If the change from one, so I'm going to underline what you are, if the change from one y value to the next is the same, and the change from one x value to the next is the same, the rate of change is constant and the relationship is linear. So this all of this, and all of this. We cut out a little bit. So you're not writing that, or that, or that, or that. We didn't cut out a lot, but we cut out a little bit. Faith, are you done? I'll wait and fix it later. Anybody need more time? Tyrese, you done?
No.
Kimani, did you finish writing? Jacob, you done? Tyrese, you almost done?
Yep.
Are you ready? Alright, so for finding the slope of each line, let's, this is like your problems 4 through 6. So we just talked about problems 1 through 3. This is an example of your problems, so problems 4 through 6. 4 through 6 are going to give you a line. My lines have points on it, yours don't, but you can pick any points that you want. So remember, this is where you're going to use rise over run. So we're going to use m equals rise over run, and we're going to count from one point to the next. We're only going to do one of these. Let me ask you this. Looking at this line, it goes up from left to right. Does it have a positive slope, a negative slope, a zero slope, or an undefined slope if it goes up from left to right? Up from left to right is positive. Down from left to right is negative. You're right, Shmari. A flat line, zero slope. A vertical, straight up and down line, undefined slope, remember. Right, so here, we're going to go ahead and I'm going to show you how to do this one. You don't even have to write this one if you don't want to, but I do want, you don't have to draw the picture. just write what I'm writing. You're writing this, and we're going to write this. And then I'm going to do this example with you. You're going to write it, but you don't have to draw the picture. This is what we learned how to do this yesterday, but I'm reviewing it because it's on your worksheet today. So I'm going to find the slope. Remember, m is the slope. M equals the slope. Right now you're writing, you don't have to draw the graph, but you're writing everything else I have here. You got this written too, Armani? Done here? Okay, awesome. Alright, so I'm not going to use the points that they have dots on because yours doesn't have dots. So remember yesterday I said you can pick any 2 points in this line and count from one to the other. And you plug into this rise over run formula. So I'm going to pick this point. And I'm going to pick this point. They cross at nice, neat intersections of this grid so I can count in whole numbers. So I'm going to go from the bottom to the top. So I'm counting up and over like I'm driving a car on city blocks. So I'm going to start from this one. I'm going to count up until I get even with this next point. So to go up, I'm going to go up 1, 2, 3, 4, 5. So that is up 5. That's my rise. Right now you're writing what I'm writing down here. So we go up 5. So you should be through here. So this is what we're writing now. We're plugging into this formula. So the rise is up 5. And up on the coordinate plane, we should remember, is positive 5. So that's positive 5. Then I'm going to go to the right 1, 2, 3, 4, 5 as well. So that's right 5. And we have to remember, if we go right on the coordinate plane, that's also positive. So up is positive for y, right is positive for x. Down is negative for y, and left is negative for x. That should be reviewed. So positive, right 5 is a positive 5. Now we simplify or do the math. 5 divided by 5 is 1. So the slope, for that example, that's how you do 4, 5, and 6 is 1. How about this? We're going to do one of your problems on for number 7. So that will give you less problems to do for homework. How's that? So far we have not done that. But for number 7, we're going to do one of your homework problems. Number 7 is your homework problem. So our next example is find the slope if you're given 2 problems. Given 2 points on the line. So if you look at the directions on your homework, find the slope of the line that passes through each pair of points. This is number 7 on your homework. So the 2 points are 2, 1 and 0, 0. So we're using the formula m equals y minus y now, divided by x minus x. So is 2 an x coordinate or a y coordinate? An x coordinate. Is 1 a y coordinate or an x coordinate? No, 1's a y coordinate, right? All ordered pairs have the first coordinate is x, the second is y. So this is an x and this is a y. So we're going to plug into this formula now. Y minus y, so I'm going to give myself a new blank fraction here with this formula. So I'm going to do y minus y, so 1 minus 0 over 2 minus 0. Yep. You can write this one on your homework. I won't count off if you don't put it in your notes, as long as you have it on your homework. and now we do the math, and we could do this on the calculator. If we do this on the calculator, you have to remember to put parentheses around it. So we probably should get in the habit of putting parentheses around the formula. But if you put it in the calculator, 1 minus 0 is 1, over 2 minus 0 is 2. If you divide that on the calculator, you're going to get 0.5. So either of these would be acceptable. So that is the answer to number 7. You have to show me that work. That's how you get credit for this problem. Actually, all right, caught up with me? 13, 14, and 15, I'll just give you a hint, they don't require any work. I explained them yesterday, and I said after yesterday, you don't have to show me any work, but you need to look back at your notes if you don't know what I'm talking about. So look back at your notes. All right, we're going to go on to problems like 16 through 19. You're only doing 17 and 19. You don't have to tell to write this. This is you are going to write problems 17 and 19. Those are the only ones you're doing. I'm going to show you how to do them. I am going to need you to, you don't have to write the directions. These are the directions on your worksheet, so we're going to save a little time there. But if they give you a word problem, and these are the directions, so these are the same directions that are on your worksheet for 17 and 19. Actually, let's not do these two. Let's do number 16 on your worksheet. And that way you don't have to write a bunch of stuff. So we're going to use problem 16 for your example. Remember, you're not assigned problem 16. This is your example. But now we can look at problem 16. Says the cost of tickets to the amusement park is $19.50 for one ticket and $78 for 4 tickets. The question is, does that situation represent a positive slope, a negative slope, a 0 slope, or an undefined slope? Sorry? Number 16. So everybody look at number 16. I think I have it on here. All right. So that's problem 16. The cost of tickets to the amusement park is $19.50 for one ticket and $78 for 4 tickets. So we have to be able to tell, is it a positive or negative slope, or a 0 or undefined slope? Which one of those 4 is it? Well, every time we buy one ticket, the price increases, right? So for one ticket, it's going to be $19.50. Does that make sense? We can refer to that as an ordered pair. When we buy one ticket, we pay $19.50. When we buy 4 tickets, we pay $78. So the cost depends on the number of tickets we buy. Does that make sense? You guys have all bought tickets to the movies before, right? So what is the relationship? Is it positive, negative, 0, or undefined? So we're going from 1 to 4. That's a positive increase. Would you agree? So the x's increase, so that's a positive. And the y's go up from 1950 to 78, so that's a positive. So if you have 2 positives, positive times a positive is a positive, so we know I have a positive slope. Another way to do it is just to plug it into the slope formula, and we have to do that anyway. We're going to find the slope because they asked us to do that. So if they ask us to find the slope, we do need to be able to write them as ordered pairs. We need to know what is an x value and what is the y value. Does that make sense, Faith? So now I use my slope formula. So y minus y, 1950 minus 78, the order doesn't matter, divided by x minus x, 1 minus 4. Sometimes, remember, you'll see this formula with subscripts. All you have to remember is that order pairs have to line up on top of each other. This y has to have its x right below it. This y has to have its x right below it. Does that make sense, Wasim? Does that make sense, Sam? So now I'm going to use my calculator and do this math. And that's going to give me negative 5850. And I can do it all at one time. 1950 minus 78, if I put it in parentheses, I could anyway. Divided by 1 minus 4 on my calculator is negative 3. Now I'm going to divide negative 58.5 by negative 3. And I'm going to get a slope of 1950. Doesn't get a dollar sign or anything. The slope is a numerical value there. Jeremiah, you writing what I'm writing? Does that make sense? So we could find the slope first and then say it's a positive slope. So if this part didn't make sense to you, if you were like, huh? Just find the slope. And that's a positive number, so the slope is positive. If the slope winds up being numerically 0, then we know the slope is 0. Does that make sense, Jacob? Does that make sense, Jalen? So that's how you do 17 and 19. We're going to look at the problems, how to do problem 21. And first off, we have to talk about what is an independent variable. So we are going to go ahead and put this in our notes. An independent variable is usually the x coordinate, and it does not depend on the other variable. Usually, if you have time or distance, those are almost always independent variables, so they're almost always going to be your x coordinate. Dependent variables, usually we use the variable y for those, and it depends on the other variable. Like in that example we just did, the cost depended on how many tickets we bought. That made the number of tickets the independent variable, and the cost the dependent variable. The number of tickets we put in the x spot, the total cost we put in the y spot. Does that make sense? Tavion, does that make sense? So now we're going to look at how to do problem 20. I'm sorry, problem 21 is yours. So we're going to do problem 20. It's on your worksheet. That way you don't have to write a bunch of stuff. So these are the directions. You don't have to write it. These are the directions for your problem 21. State the independent variable and the dependent variable in each situation. Then find the rate of change for each situation. You need to know that the rate of change is just the slope. But we call it a rate of change when we're talking about a real world problem. You caught up with me? All right, I'm gonna copy number 20. So we can do that one together if I can find it. All right, so you don't have to write this problem because you've got it, you can do it on your worksheet. So I should see number 16 and number 7 or number 16 done even though I didn't assign it to you because we're doing it together. That makes sense? Alright, I forgot to paste it. Alright, let me find it. Alright, so Shelley delivered 12 newspapers after 20 minutes and 36 newspapers after 60 minutes. So which one of these is going to be the independent? Which one of these is going to be the dependent? So remember, the independent is going to be our x coordinate. So you're going to write what I'm writing. The independent is going to be the x, and the dependent is going to be the y. I gave you an example of what some independent examples or variables are. What did I say? Jamisha? I'm sorry, it's not number 16, it's number 20. Thank you. So you should have number 20 done on your worksheet so you don't have to write it in your notes. So independent variable, dependent variable. So we're talking about the number of newspapers and the time it takes to deliver, right? The number of newspapers and the time it takes to deliver. So what did we say are some examples of independent variables? Time, right? So the number of papers delivered depends on how much time. So the independent variable here is the number of minutes. The dependent variable is the number of papers. So we can write these as, or this situation is ordered pairs. So we're going to give ourselves two ordered pairs. So after 20 minutes, that's my X, 20 minutes, deliver 12 newspapers, right? After 60 minutes, that's my X, it's the time, we delivered 36 newspapers. So I have these two ordered pairs now. I have an X value and a Y value, an X value and a Y value. Now I can use my formula to find the slope. So the slope equals Y minus Y. Doesn't matter which Y I put first as long as I put its X with it, right? So if I put this Y first in the top, I've got to put this X first on the bottom. So 12 minus 36 divided by 20 minus 60. And then I can just do that on my calculator. 12 minus 36 is negative 24. Divided by 20 minus 4 is negative 20. I could do it all in one step if I use grouping symbols up here. If I use parentheses, I can do the whole thing on my calculator just like that. Negative 24 divided by negative 20 gives me 1.2. So my slope, which is my rate of change, is 1.2. It's a positive number, so it's a positive slope. As the number of minutes increases, the number of papers that are delivered increases. Okay? Any questions on that one? Did I subtract something wrong? 20 minus 60. Yeah, that's my bad. I did the 40 in my head. I'm famous for that. Or infamous, I should say. So this is 20. Is that what you're going to tell me, Jacob?
Yeah.
20 minus 60, so this should be 40 here. Negative 40. So it's not 1.2. It's whatever negative 24 divided by negative 40 is. So it's going to be 0.6. Still a positive slope. And it's okay that it's a decimal. If you wanted to turn it into a fraction, remember we know how to do it on the calculator. We second, then the arrow button, and it would show you that it's 3/5. You guys have two of the bottom ones to do, 31 and 33. Would you like me to do one of those for you now?
Yes.
Okay. You got to work with me. That we will have cut down a couple of your problems. So let's just go ahead and do 31. This is one of your homework problems we're doing. If you're not paying attention, then it's one more problem that you have to do on your own. All right, so these are the two ordered pairs they give us, but the problem is they don't give me that y coordinate. They do give me the slope though, and they tell me it's 1/4. So I'm going to plug into the slope formula, which is y minus the slope equals the y's minus the y's divided by the x minus the x's. Everywhere, so this is the slope, I'm going to put in the given 1/4 there. Y minus y is going to be 4 minus y. And x minus x is going to be 7 minus 3. So I'm going to go ahead and simplify. 7 minus 3 is 4. Are you with me so far? So all we did is this was the given information. This is the problem. This is the formula you have to use. M stands for the slope. They gave us the slope. Shamara, you writing what I'm writing? The y coordinate minus the y coordinate, that's the unknown here. So now we're going to put parentheses around this, and we're going to cross multiply and get rid of these fractions. Well, we can multiply everything by 4 or cross multiply. Let's multiply everything by 4. That's what we've been doing. So 4 times 1/4 is 4/4. So that's going to be 1. And 4 times this, we're not going to multiply by what's in there. Remember, that's a 1/4. So that's also going to be 4 times 1/4, so that's going to be 1 equals 1 times 4 minus y. If you don't like that way, we can do it another way. We could also cross multiply, and you'll see that we'd get the same thing. That's going to be 4 equals 4 times 4 minus y. We can divide both sides by 4 here and get 1 equals 4 minus y. So you can do it either way. So this is 1 equals 4 minus y. Now we have a one-step equation, but the tricky part of this is that's a negative there, right? So I'm going to subtract 4 from both sides. Now I've got negative 3 equals the opposite of y. Y does not equal negative 3. You're going to divide both sides by negative 1, and y equals 3. Does that make sense? All right. We got through an example of everything on your worksheet, I think. And we did 2 problems from your work. Remember, you don't have to do all of 17 through 33. You're doing the odds. But you do have to do all of 1 through 15.